Bismillahirrahmanirrahim. In this lecture, I would like to discuss with you about the non-homogeneous differential equation. These are the higher order non-homogeneous differential equation. So, how to recognize a higher order different non-homogeneous differential equation? The form of this differential equation would be like that. There would be some uh, coefficients of the differential that might be one, and another uh, order less than this order, and so on up to the linear term. And the right hand side, that would be a polynomial or the function of x, or the function of dependent variables f of x. Or this equation also can be written as uh, some coefficient differential, that is capital D. Capital D, as I already told you, that would be d upon dx. For instance, we use capital D, so dny plus an minus 1 dn minus 1 y, and so on up to the a naught y is equal to f of x, and taking common y from the entire equation, so that the equation becomes an dn plus an minus 1 dn minus 1, and so on up to a naught is equal to into y is equal to f of x. This equation is known as higher order non-homogeneous differential equation, and the solution of this types of differential equation will be y is equal to yc plus yp. What is yc? Yc is the complementary function, and yp is the particular integral. So the solution of non-homogeneous differential equation consists of two parts. So I will explain you one by one. As I told you that yc, how to obtain yc, it is that part we already have learned, the solution of homogeneous higher order homogeneous differential equation. So this yc, that would be obtained from the homogeneous part, and this yp will be the solution of the non-homogeneous part of the differential equation, and the combined solution of this entire differential equation, non-homogeneous differential equation, is called the general solution of this differential equation. As you know, as I explained you, what is yc? Yc is the complementary function, and yp is the particular integral. So yc may be obtained as we have the solution from the homogeneous differential equation, and yp may obtain by the several techniques, depends on the function given on the right hand side, that is f of x. And as I told you that where this capital D is denoted by d upon dx. So yc is the solution of the left hand side as a homogeneous part, and the yp is the solution of right hand side function, that is particular integral. So first, it means that what, yc is equal to f of d, f of dy is equal to 0, right? And yp is equal to y is equal to f of x upon f of d. So when you will shift this, uh, what is this equation? This equation is showing you the right hand side when we are substituting f of x is equal to 0. So the non-homogeneous becomes homogeneous differential equation. Now we will proceed the solution of this equation as we have solved earlier the solution of homogeneous part of the differential equation. So now we will discuss about little about the solution of non-homogeneous differential equation, what kind of solution you might have, or what kind of functions f of x will be given to you. The very first case, if the function f of x, which is given at the right hand side, if function is like a exponential bx, something like that, then then for getting the solution, this can be converted into a exponential bx upon f of d. For instance, for getting the solution, we will substitute b, for instance d, in the function, so that we will get the solution. But we have to keep in mind that f of b must not be equal to 0. If f of b is equal to, if f of b is equal to 0, it means that you cannot proceed the solution. So you have to keep in mind that if and only this case is if it's only if f of b is equal to 0, a exponential a bx is equal to a exponential bx upon f of b, right? So if this is not equal to 0, so for further what we will do, we will do what? If f of b not equal to 0, you will proceed further. In that case, what happened? A will remain same, exponential bx. So I would like to continue regarding uh, the solution. That is, if that would be the solution in that case when a exponential bx upon f of d becomes a exponential bx upon f of b. That would be the solution of when we have f of x a exponential bx, if and only if when f of b not equal to 0. If f of b is equal to 0, what we have to do, we'll perform the next step. In case when f of b is equal to 0, in that case that would be a exponential bx, f of d becomes x times a exponential bx f prime d. So what we have to do, again we will substitute b is equal to 0 in the f prime f of d, so that the solution, that would be a final solution x a exponential bx upon f prime b. This will be, we can stop your here our solution if f prime b not equal to 0. If f prime b is equal to 0, this is not equal to 0, right? If consider if again f prime b is equal to 0, in that case what happened, again we will proceed the solution and we will write it this x a exponential bx f prime d. That would be what? That would be again x square a exponential bx f double prime d, and now we will substitute the value of b, for instance d. So the solution becomes x square a exponential bx upon f double prime b. In case if agar if f double prime b is again is equal to 0, so we will proceed further this solution in case of when f double prime will be equal to 0. So this will be proceed until we'll get the final answer. So that if f this will be proceed until f double prime will be equal to, we will not get the f double prime is equal to, so on and unto the process until f of n f of b is equal to 0. When we will get f of b is equal to 0, at that time we will f of n not equal to 0, we will stop our process. That would be the final answer of the non-homogeneous part of the differential equation. Second property of the non-homogeneous side is differential of nth order differential equation of a exponential bx becomes a b power n exponential bx. That will be obtained by replacing d. What is d? D is the differential, that is d upon dx by b. And the third property is f of d a exponential bx, that would be a f of b exponential bx. And the next property is dn a exponential bx multiply by p. P is any polynomial or any function, algebraic function or any kind of function. In that case we can write it as a exponential bx d plus b power n into p. So here we will also, what we have to do, here we will replace for instance d by d plus b, so that we will get the solution in that case. In another case, when we have a exponential bx upon f of d at the right hand side, so that would be written as a exponential bx upon f of b. And in another case, when we have a exponential bx multiply p f of d, in that case that would be is equal to what? A exponential bx dot p upon f of d plus b. This is the similar as we have explained you in property number 1. Here this is this in property number 1, and this one is in property number 4 here. Now the next one is in case of trigonometric function. For example, if we have sine ax upon f of d square, uh, so all the values which consist of d square, we will replace what? Sine ax will remain same, and for instance d square only, for instance d square we will replace minus a square, from where we will obtain the value of a, that would be the coefficient of x in the angle of a. So that what we have to do, we will replace by d square by minus a square, so that we will get the solutions. Similarly, in case of cos ax f of d square, in that case also we perform the same procedure. For instance minus a d square, we will for instance d square we will substitute minus a square, so that we will get the solution. Now number 3 case, number next case is when we have uh, sine bx upon f of d, not d square. So you have to remember that in that case we will write the expression something like that. This is the imaginary part, sine is the imaginary part of a complex number. So that we can write it as imaginary part im of exponential iota bx f of d, or it can be written as, if you want to obtain the solution, that would be imaginary part of exponential iota bx f of iota b. For instance d, you will substitute iota b, and you know that the value of exponential iota b, it is the complex number exponential iota theta, that is equal to what? Exponential iota theta, we already know that the value of exponential iota theta is uh, cos theta plus iota sin theta, right? That is exponential iota theta. So the real part or imaginary part, this is the real part, cos theta plus iota sin theta. So this is the Euler formula or exponential iota theta complex number. uh, for instance a plus iota b, for instance x plus a plus iota b, z is equal to a plus iota b. uh, we can write it as exponential iota theta cos theta plus iota sin theta. So that is why we are taking here sine as an imaginary part of the complex number. Now the next case is when we have cos bx upon f of d. In that case we will write it as real part of exponential iota bx upon f of d, and we will substitute iota b, for instance d, to get the solution of uh, when we have cos bx upon f of d. And directly when we have uh, d square of sine bx or d square of cos bx, in both cases the solution becomes b square sin bx or minus b square cos bx, or so that in that case uh, uh, when we have d square in the denominator with sin bx upon d square cos bx upon t square, in that case the solution becomes sin bx upon minus b square and cos bx upon minus b square. These are quite similar formulae, and here, and you know that what is mean by the d of sine. D of sine is the differential of sine, and d of cos is the differential of cos, and you know that the derivative of sine is cos, and the derivative of cos is minus sine, and 1 upon d is the uh, reciprocal of the d, that is integral of sine x is minus cos x, and integral of cos x is sine x. So these are the values which we already have learned in the intermediate classes. For further explanation, I would like to solve a problem of a non-homogeneous differential equation. So this is the given problem: d square minus 10d plus 24 into y is equal to 3 exponential x. So we will write it as equation number 1. So this equation is a non-homogeneous differential equation because we have non-zero term at the right hand side, and higher order, the maximum order of the differential equation is 2, that is more than 1. So this kind of equations are higher order differential equation or second order differential equation. So how to proceed the solution? First of all, we will find the complementary part of this differential equation for yc. So what we have to do, from the left hand side, we taking the d square minus 10d plus 24 is equal to 0. This is the characteristic equation. This is the characteristic equation. This is the characteristic equation of the above differential equation, that is d square minus 10d, or is also known as auxiliary equation. So in this case, d square minus 10d plus 24 is equal to 0. By breaking the middle term, that would be the minus 6d minus 4d. So from the factorization, we get the two factor d minus 6 and d minus 4 is equal to 0. So we have gotten the two roots, r1 is equal to 6 and r2 is equal to 4. Now the solution of left hand side becomes yc is equal to c1 exponential r1x plus c2 exponential r2x, and r1 is 6 and r2 is 4. So the yc becomes c1 exponential 6x plus c2 exponential 4x. Now we are going to find the solution of right hand side or particular integral. So how to get the solution of particular integral here? Uh, from the equation number 1, what we have to do, from equation number 1 we will transfer the function of d at the right hand side. So y, that would be y is equal to 3 exponential x upon d square minus 10d plus 24. So equate the y from equation number 1. After equating the y, we get the situation y is equal to 3 x square 3 exponential x divided by d square minus 10d plus 24. Now we will substitute the value of b here. What is the value of b? The coefficient of x is b here, that is 1. If we will substitute b is equal to 1, so that is not is equal to 0, we can directly substitute the value of b, that is exponential. So when we substitute the value of b here, for instance d, that would be 1 square minus 10 into 1 and 10 into 1 plus 24 and 15, 3 upon 15 divided by, we will cancel out, that would be exponential x upon 5. So in this case, the solution of the differential equation becomes what? Yc plus yp. General solution of the differential equation, that would be y is equal to yc plus yp, and yc is c1 exponential 6x as yp is c2 exponential 4x plus 1 upon 5 exponential x. So this is the answer of our differential equation. So um, very soon I will upload the second lecture about the more examples with more cases of the differential equation, in which you will learn more regarding the different kind of solution and how we can proceed the solution of non-homogeneous differential equation in order to solve when we have different cases. So I would like to say thank you for your like, comments and subscribe. If you think the video is useful for you, please, I would request you for the motivation, kindly like and subscribe my video. Thank you so much. Allah Hafiz.